Welcome to Thermochemistry, which is the study of energy and heat associated with a chemical reaction or physical transformations. So by the end of this lesson, you should be able to identify the two terms. One of them which is endothermic reaction and the other one which is exothermic reactions. In terms of whether or not heat is absorbed or heat is released from the system. So, and one other term that you need to know is enthalpy, which is the amount of heat changes in a chemical reactions. Just for the purpose of this case, we only going to be talking about the chemical reactions. So from one of the worksheets, you're going to have to be able to identify what a potential chemical reaction is. So I'm just going to give you a diagram. Since we're making comparisons, I'm just going to give you a two different diagram. So endothermic reactions. So I'm just going to take notes on here. It says that heat is absorbed. You will feel cooler. Exothermic reaction is just going to say heat is however released. So the effect of that one is that you will feel hotter. You will feel hot. You will feel a little bit of cold. So with this one, if you were to be using the thermometer to measure the amount of heat, whether or not it released or absorbed in a chemical reaction, this one the temperature should be higher and this one the temperature should be lower. So you're gonna have to understand in a chemical potential energy, you have this is where you start, this is your reactants, and it will undergo activation energy, and at the end heat is absorbed. So I'm just gonna stop it right here and that. So basically this is reactants. So these are the product. I want to see if you can see this, reactant and product. And the energy from reactant all the way to the activation. Okay, this is called, right here, I'm just going to say this is called activation energy. Which is the energy needed to activate a chemical reaction. For example, if this chemical reactions doesn't have enough activation energy, therefore it won't proceed to the product. So therefore reaction wouldn't occur. So let's go back to here, which is called enthalpy, which is the amount of heat changes in a chemical reaction. So it actually measured from a product in relative to the reactant. So the changes is positive. That's all you need to know, that the enthalpy is positive if it is a endothermic reaction, so feel cold. However, this is a chemical reactions, this is reactants, it undergoes a little bit of activation energy, or it could go a lot, depends. But at the end of the process, the energy of the product should be less than the reactants. So from this, I want you to go ahead and identify the activation energy and enthalpy. Let's go ahead here. This is activation energy. As you can see that the enthalpy of an exothermic reaction will be negative. I can give you one of the example. Because one of the example that you need to identify is you are going to be given the chemical reactions on the worksheets. I'm just going to show you what you need to do. So these are the worksheets that goes along with the notes. Activation energy is energy needed to activate a chemical reaction. So then you're gonna have to identify whether or not this is endo or exothermic reactions. However, your diagram has a scale, so you should be able to figure out what the amount of energy is. So when you look for part 2, you are given a chemical reaction. You are identifying whether or not they are endothermic reactions or exothermic reactions. And you're looking for, the first thing you do, you look for the sign. Positive, endo. Negative, exo. That's easy, simple rules. That's a rule of thumb. But also, I'm just going to tell you this one also. An endothermic reaction, the energy is written on the right hand side. Energy is written on the left of a chemical reaction. Energy is written on the right of chemical reaction. For example, I'm just gonna give you like A plus B plus 10 kilojoules is equal to C plus D. So these are endothermic reaction because they are written on the left hand side. However, A undergoes B plus C plus 11 kilojoules. This is an exothermic reaction because the energy is written on the right hand side, which by all means it releases energy. By all means that endothermic reaction absorb energy. I hope those are easy, simple enough. Now we're gonna accelerate the lessons to go more on the thermochemical equation, which is the equation that can be used to calculate the energy changed. So these are the equation, which is Q equal mc delta T. Q is heat, unit is in joules only, mass is in grams, specific heat is in joule per grams Celsius, and the temperature has to be in Celsius. So for this one, thermochemistry, you do not need to change the temperature to Kelvin. This one remains the same, it's just Celsius. Now what I want you to do is to go ahead and look at the questions to see what you have, and you follow the steps. Go ahead and copy the step down first. If, for example, if by all means, if you have to solve for the amount of heat needed to raise a certain element to a certain temperature, you will follow step 1, which is identify given informations. Step 2 is identify which equation can be used to apply if you want an easy way out. Question 3 is substitutions. All you have to do is substitute your known values. Step 4 is to calculate the problem. It is to solve the problem or calculate the variable. So I'm just going to make up a question. So a question is that how much heat is required to let 5 grams of water from 10 degrees Celsius to 100 degrees Celsius. So the first step, identify given information. So from this one, we have 5 grams, we have mass is equal 5 grams. the change of temperature. T final minus T initial is 100 minus 10, that's 90 Celsius. As you can see, it doesn't tell you specific heat. You have to go back here to look at the substance water 4.18. So therefore you know the C is equal to 4.18. Identify which equation can be used to apply. Since we're looking for this one is the easiest, simplest, or the easiest way. So it will be m times c times delta t. Mass is 5. Specific heat is this. Change of temperature is 90. Then all you have to do is just multiply them and solve for the problem. So my Q is equal to, you multiply them all. That would be 5 times specific heat, which is 4.18 times 90, which is equal to 1881 joules. And this is how you will solve for the heat needed to raise the temperature.